Hi Ava, this is your kinematics and vector calculus test feedback. So question number 1, you've got a correct equation. The domain of x is the range of x. And if I was to graph x against t, it starts at 3, and as t gets bigger, it then goes down. So the range of that is minus infinity to 3, which makes that the domain of x. So when you're drawing this graph, we're actually drawing it from minus infinity to 3, so it draws like this. Your range is correct, so that the starting location and the direction of motion is something you didn't include on your graph, and you need to go back to here to work out starting location. Make t equals 0. So y equals 0 and x equals 3. So I know I'm going to be starting at this point here. The other thing is you could go to graphs and tables in the CAS and do xt, yt, and actually enter the two equations and get an idea of what it looks like. Question number 2, 3 marks. You gave me the two accelerations. If I want to know if the accelerations are ever perpendicular, I want to do az of t dot aa of t and see if I get an answer of equal to 0. I don't believe that's that, because what I'll be doing is going 2 times 1 plus negative 2t times 6t, solve for t. Question number 3 was good, 4 out of 6. You've given me the velocity, you haven't given me the speed, which would be the square root of 29 squared plus 1 squared. And again, you gave me the position at t equals 2. You didn't give me the distance, remembering that it started here. So we're finding what is the distance between negative 3, 28 and 3 and 13 through until negative 1, 22 to 17. So use the square root of this one minus this one squared plus 17 minus 13, 4 squared. Question number 4. We need to do some work on projectiles. And because we couldn't come up with the equations, we couldn't do any of the questions. Question number 5, 10 out of 10, which is good. Good graph, the equation, good graph, the equation, and that interpretation of those graphs is all wonderful. Question number 6, 6 out of 7, which is really good. The only thing you got wrong was in the 30th second. It's not from 0 to 30 seconds, it's just between the 30th second and the 31st second. So during that 1 second, since it's travelling at a constant 24 metres per second, in that second it would travel 24 metres. The next question, we're getting to the end where we're running out of time. So that is correct. No, it's not correct. We're wanting, find the first time it's stationary. We're wanting to take the derivative of displacement to get to velocity, not the antiderivative. That's all correct. We need to do some replacements. That's the correct replacement, but you didn't replace it properly. Oh, I know about that. This one here don't involve t, because you want to know what the velocity is in terms of displacement, so you don't integrate with respect to t. You can't do that because we don't have any t's anyway. And this one here, you are so correct in what you are doing, but e to the minus t on 5 as t goes to infinity, this one goes to 0. It doesn't go to e to the 0, which would give you 1. Very good. you need to do some work on selecting the appropriate replacements for A and projectiles. And they're the two things that were at the end of the vector calculus chapter. Well done, keep it up.